Right, so today we'll start with quiz 6, and we'll start with number 3. So number 3 is right here. It says use this midpoint rule to evaluate this or to approximate this definite integral. And so the idea is you want to graph the integrand here. So take out your graphing calculator, and you hit second square root, and take x raised to the 3. Right, add 1 in parentheses. And then make your window from 2 to 10. Okay, so we want to just see what the graph's going to look like and zoom fit it. And once we get the graph, we can start drawing the picture here. So here's the picture. Okay, it starts down here and then it goes up. And we start at 2. And we're going all the way to 10. And we have to make 4 rectangles. So we have to make 4 divisions between 2 and 10. So you get 2, 4, 6, and 8. And then it says use the midpoint rule. So the idea is find the midpoint. So the midpoint between 2 and 4 is 5. Oh, sorry, 3. So it's 3. The midpoint between 4 and 6 is 5. 6 and 8 is 7. 8 and 10 is 9. And we have to find the corresponding heights here. So remember, this is the function f of x equal to the square root of x cubed plus 1, and it comes from right here. And so I just plug in 3 for x, and I get my answer of 3 cubed, which is 27 plus 1, so 28. Take the square root of that. Plug in 5, I get 125 plus 1, so 126. I plug in 7, and I'm going to use my calculator for this one, so 7 raised to the 3 plus 1. And I get 344. And then I plug in 9, so 9 raised to the 3 plus 1. And I get 730, so square root of 730. All right, this is how I make my rectangles. I use the midpoint. All right, so I use the midpoint here to make my rectangles. Oops, that's not a very good rectangle, but you get the idea. And the midpoint here to make my rectangle. And I just have to compute the area of these rectangles. So the area of the first rectangle, to find the area of this, it's just root 28 times 2 plus root 126 times 2. That's the area of this second rectangle, plus the square root of 344 times 2. That's the area of this rectangle. And then plus the square root of 730 times 2. And I put this into my calculator, and I get approximately, right? So put in your calculator, second square root, 28. And I'll skip the 2's for right now, so plus second square root, 126, plus second square root, 344, plus second square root 730. Hit enter. Oh, let me mess this all up. Right, I have to put parentheses after all these. So come back up here, and I better put parentheses, otherwise it won't be right. Right, second insert. I have to put a parenthesis here. Put a parenthesis here. Now it'll be fine. So hit enter. Multiply it by 2, and I get my answer of approximately 124 to 4 decimal places, 0.1644. All right, so that's how you do number 3. Okay, let's look now at number 6. All right, so number 6 is right here. All right, so how do we do this one? So let me copy it. All right, paste it. Okay. So on this one, it says what? It says from 1960 to 2010, a certain money stock measure was growing at this rate of $1 billion per year, or per decade. Right, so you got to be careful here. Per decade. So we have this where X is a number of decades since 1950, so decades since 1950. Find the total increase in the money stock measure from 1960 to 2010. All right, so what it's asking you to do basically is to integrate this function. So I'm going to take the integral of 35 e to the 1/2 x, so 1/2 x dx. All right. I don't know why that thing is there, so I'll get rid of this. Let's get rid of that. All right, so this is dx. And I'm going to go from, it goes from 1960 to 2010, and this is decades since 1950. So 1960 is actually 1 decade after 1950, and 2010 is 6 decades after 1950, right? So you go 1960, 1970, 1980, 1990, 2000, 2010. I'm going to use my calculator to figure out this to the nearest $1 billion. So I take out my calculator. I'm going to hit y equals and plug in this function, so clear out this thing. And so I have 35 second ln to the 1 divided by 2, right, times x. I just put an x, right, parenthesis. And I'll make my window from 1 to 6. I'll zoom fit it. And so we can draw the graph here. So I'm going from 1 to 6. I'm looking for this area. And I just hit second trace. Go down to number 7. And the lower limit is 1. The upper limit is 6. Hit enter. And we'll round to the nearest billion. So 1,291, since it's 0.5 billion dollars. All right, the next one I want to look at is number 8. Let's go down here to number 8. Oh, yeah. All right, so number 8. Okay, oops, that's not number 8. Let's redo this. So go back. Guess it didn't copy. All right, here's number 8. Okay, so to find this indefinite integral, it says use C for the constant of integration. How do we do this? Well, the first thing is I have to write these as powers of x. So this is actually equal to the integral of 32 times x to some power. So it's x is raised to the 5th power, and you're taking the 3rd root, so it's 5 divided by 3 minus, I have another 32 here, and then x to some power. Now the exponent's negative because it's in the denominator, and it's actually the same thing, then 5/3, because it's x is to the 5th power, and it's a 3rd root. I have not taken the integral, I just wrote it in a different form, which means the same thing. All right, now I'm going to integrate. So to integrate, I add 1 and divide by it. So I have 32 x to the 5/3. I add 1 and divide by it. All right, so 5/3 plus 1. Minus, I have 32, and I add 1. So I have 5/3, and I negative 5/3. I add 1, and I divide by it. And of course, I have plus C. All right, so now I do the arithmetic. So I have 32 x to the what? Well, 5/3 plus 1, right? 5/3 plus 1 is like 5/3 plus 3 over 3, so this is 8/3, right? Divided by 8/3 minus 32 x to the, this is minus 5/3 plus a 3 over 3, so that's minus 2/3, right? Divided by minus 2/3 plus C. And so this is equal to, right, when you divide by a fraction, you multiply by the reciprocal. So this is going to be equal to 32 times 3/8. All right, so let's just do it 32 times 3/8, right? X to the 8/3. And then minus a minus is a plus, so I'll get plus 32 times 3/2, x to the minus 2/3 plus c, which is equal to, it's equal to what? Well, 8 and 32 cancel, so I get a 4 here, so I have 12 x to the 8/3, right, plus 32 and 2's, they cancel, so I get 16 times 3, and 16 times 3 is 48, x to the minus 2/3 plus c. And that's how they left it, so we can leave it like that. Also, you could also rewrite this if you really want to. This is the same as 12, and now this is the cube root, and so this is actually x squared times the cube root of x squared plus 48 over the cube root of x squared plus c. If you want, you can write it like that, but this is fine. All right, the last one I want to look at on quiz 6 is number 10. So on number 10, what do we have? All right, so here's number 10. Okay, so on number 10, we want to do this integral of 8 over x minus 7 over x squared. So here you have to be careful, right? Remember, you don't want to write this one as a power because it's one of your 4 types. So when you integrate over 8 over x, you're actually going to get 8 ln, absolute value of x. But the next one you do, so this is 7x to the minus 2 dx. And so now I'm going to integrate it. So I get 8 ln, absolute value of x, minus 7 x to the add 1 and divide by it. And then you add c on the very end. And so this is equal to 8 ln, absolute value of x. And then I have minus 7x to the negative 1, right? Negative 2 plus 1 is a negative 1, divided by negative 1 plus c. And I can just rewrite that as 8 ln, absolute value of x, minus a minus is a plus, and I can write this as 7 over x, because the exponent's negative, plus c. Okay, so after that, let's take a look at your homework now. So let's pull it up. There are a couple problems I want to look at on here. And so on this one, let's look at number 6, right? So now this was on using the fundamental theorem of calculus and computing areas. So let's find number 6. So number 6, right, which is this one right here. Oops. There we go. All right, so on number 6, you're supposed to find the area of that shaded region. So let's do that. All right, so the way this works is you got to create an integral. And so we're going to go from obviously 0 to 2. And what we'll do is we'll find the area underneath this curve in red. All right, so all the way down. All right, so that's going to be the integral from 0 to 2 of 2e to the x dx. So that's the area in red. And then we'll take off underneath here this area in blue. I'll actually subtract that. So we'll say minus the integral from 0 to 2 of 3x minus 1 dx. Right? And don't worry that that's negative. It's good that that's negative, because when you take off a negative, right, remember the definite integral will count that as negative down there. It'll make it positive, so actually it'll give us this shaded region in between. All right, so what we can do then on here is we actually can combine these two integrals. So this is actually equal to, the integral from 0 to 2 of 2e to the x, right, minus 3x, right, and then minus a minus, so then this becomes plus 1 dx. And I can integrate this. The integral of 2e to the x is just 2e to the x minus 3x squared divided by 2, and then plus an x from, I don't need to write plus c because it's a definite integral, from 0 to 2. And the idea is I plug in 2, so I get 2 times e squared minus 3 times 2 squared, which is 4, divided by 2, plus 2. And then when I plug in 0, I have to be careful here because I do get something else other than 0, because when I plug in 0 for x in the e function, the exponential function, I actually get a 1 here. And then, of course, the other terms are 0, so minus 0. Right? If you plug in 0 here, you get 0. If you plug in 0 there, you get 0. And so this is actually equal to, then, 2e squared minus, the 2's cancel here, so the 4 and 2 will cancel, so I'll get 6 plus 2. Minus a 2, because 2e to the 0 is just a 2. And so this is equal to 2e squared minus, the 2's will cancel here, and I just get minus 6. And of course it's units squared because I'm finding an area. Alright, so on this one, in a little box, I put 2e squared minus 6, just like I found here. Alright, the next problem I want to look at is number 8. So let's come over here and scroll down to number 8. Okay. So on number 8, let's see what we have. Alright. So on this one, we're supposed to find the area of the region bounded by the parabola y equals x 4x squared, the tangent line to this parabola at 1, 4, and the x-axis. Right, so how do we do this? Well, maybe we should draw a graph first. So let's get a graph going over here. So hit y equals. Let's clear this out. And then we have 4 times x raised to the 2. And let's just go, we want to look at 1, 4, so let's go from 0 to 5, let's say. So zoom fit. So what do we have? Alright, so we get this graph. We went from 0 to 5. So 0 to 5. And we have the parabola here. Alright, so this is y equals 4x squared. And on here there's a point. Let's just put it right here. Here's a point 1, 4. So 1, 4. And of course there's a tangent line there, so we can draw the tangent line. So here's the tangent line, and actually we probably just draw a line. So there's a tangent line right there. Let's make this better. So there's a tangent line right there, and there's the x-axis, and in between is the area I'm trying to compute. All right, so on here I'm trying to actually find this area right here. And so what I'm going to do, and I'm going from here to 1, what I'm going to do is I'm going to find the area in blue. So let's do this in blue underneath the curve right here. So that's the integral from 0 to 1 of 4x squared dx. And then I'm going to take off. What am I going to take off? Well, I'm going to take off the area underneath the tangent line. So that would be the integral from whatever this point is, question mark. So question mark, right, to 1, whatever the tangent line, the formula for the tangent line is, so another question mark I have to go find, right, dx. All right, so first, let's go find the equation of the tangent line. So let's do that. So to do that, I need to first, I have a point, I need slope. So find y prime. Y prime is equal to 8x, right? Derivative gives me slope, rate of change, and so I plug in 1, so y prime of 1 is equal to 8. Right, so my slope is 8. My slope is 8. My point is 1, 4. I can use point slope form then, my minus y1 equals m times x minus x1 to find the equation of that line. So I have y minus 4 equals 8 times x minus 1. And so I have y minus 4 equals an 8x minus an 8. And so y is equal to 8x, add 4 to both sides, so minus 4. Okay, so that gives me something. I can actually put what I need to put here. This is going to be 8x minus 4. Great. Now this question mark, right, that's where it intersects the x-axis. Notice the height, when it intersects the x-axis, it's 0. Right? So I just got to figure out when the height here is 0. So when is 8x minus 4 equal to 0? And so I can solve this for x. So I move over the 4, divide both sides by 8. Oops. Did that backwards. Right, divide both sides by 8, so 4 over 8, and we get x equal to 1/2. And so this question mark right here, I can erase it now, and I can put my 1/2. So 1/2. All right, I'm going to do these two integrals separately, so this is going to be equal to 4x cubed, right, over 3 from 0 to 1, minus what? Minus 8x squared over 2 minus 4x from 1/2 to 1. Right, so this is equal to, now I can plug in the 1, so I get 4/3 minus, plug in 0, and I get out 0 there. So there's that one term. And minus, I can simplify this a little bit, so 8 and 2 will cancel. I get 4x squared minus 4x from 1/2 to 1. And so this is equal to, and I just keep on going, right, 4/3 minus, and now I plug in a 1, and so when I plug in a 1, I get 4 minus 4, which is actually a 0, minus, now I plug in a 1/2, and so I get 4 times 1/2 squared is 1/4, minus 4 times a 1/2 is a 2, and just keep going. So this is 4/3 minus, and I have a 0 here for 4 minus 4, minus, I have a 1, because the 4s will cancel, minus 2, which equals, again, 4/3 stays, and then minus, all right, so here that's just a 0, and a minus then becomes a plus, and this is a -1. All right, so this is equal to 4/3 minus 1, which equals 1/3, and this is units squared. All right, so if I did everything right, my answer should match up with their answer up here, which was 1/3. So that's a really tough one. I probably wouldn't put this one on an exam, but it's a good one to kind of test and bring everything together. You know, find the equation of the tangent line, using a picture, you know, to solve the problems, setting up the integrals. It's a good one to test your knowledge of these, you know, these integrals and finding area between curves. And I think that's all I wanted to talk about on here. Let's see, is there any more? Nope. And that's it. We're going to end with that one. All right, so today's lecture, what we want to talk about is a type of integration technique, which is called integration by substitution. So if you look on the slide on the right, what it says is how do we integrate this thing? Right, so how are we going to integrate 2x times the quantity x squared minus 1 to the 10th power dx? And the idea is we're going to make a substitution that's going to turn it into one of our four types. So let me remind you what are our four types. So we have an integral of a constant, dx, is equal to a constant times x plus c. And then we have the integral of a power of x. Right? So the integral of x to the n, right? The integral of x to the n dx is equal to, you add 1 to it, so n plus 1, and you divide by it, n plus 1 plus c. And we have to remember n can't be equal to negative 1, because that's going to be taken care of in the fourth case down here. And the third type is the integral of e to the x dx. Right? The integral of this is just e to the x plus c. And finally, the integral of 1 over x, so this is when n is equal to negative 1, dx is equal to ln and then the nasty absolute value of x plus c. All right, so these are our four types. And so if we want to integrate something, we have to turn it into one of these four types so we can get rid of basically this integral sign, this s, and this dx. And that's the only way we can do this. And so how can we integrate this? And so what we're going to do is we're going to use a technique, a method that is called integration by substitution. So what is integration by substitution? All right, let's look at an example. All right, so our first example, which is going to be just what we had before. So example 1, we want to find the following indefinite integral. I'm going to take part A, the integral of 2x, right, just the one we had before, x squared minus 1 to the 10th dx. And so I want to explain to you what this integration by substitution is. And the idea is you're going to make a substitution. So we're going to let a letter u, and we'll always use u, and we're going to let it equal something over here. And the idea, right, there are two ways to think about this. So let's look at a slide here. So the trick is you can let u be the thing on the inside, or look for a function and its derivative. All right, so let's think about the thing on the inside. So if I said let u be the thing on the inside, you have two choices, right? Which one would you choose? It's either the 2x or the x squared minus 1 to the x squared minus 1. Which one is the thing on the inside? Well, obviously the x squared minus 1. And if you choose that, you'll be okay, because when you take a derivative, so the idea is differentiate both sides. So we'll write du equals, and take the derivative of x squared minus 1. And so you get 2x, and then you write dx on this side. All right, so du is equal to 2x, and you write dx over here. You're going to be able then to substitute back in and get your answer. All right, so this is going to equal, and let me change colors here. So what I'm going to do is I'm going to find my u. So here's my u right there. So there's my u. Oh, and let's use, instead of a circle, let me use a box. So here's my u. All right, so where I see x squared minus 1, I'm going to write a u. All right, so I have an integral, and I have my u here. So this is u to the 10th. And then I have this 2x dx, but that's right here. So 2x dx, right, this 2x dx, this is the same thing as that. So where I see this, I can just replace that with du. And so I made a substitution. I let u be x squared minus 1, and the derivative of u is 2x, and I write dx on this side. I mean, the idea here is actually you're saying, du over dx is equal to 2x. And that's dx. And then you're just multiplying both sides by dx to get du equal to 2x dx. And that's sort of the idea. But typically we just do this all in one step. Du equals 2x dx. And then we just substitute back in, just replace the things. And then I can integrate u to the 10th. It's just a power rule, right? You add 1. So that's u to the 11th divided by 11 plus c. And then I resubstitute back in, right? So I plug back in for u. And so I get my final answer of x squared plus 1 to the 10th, all plus c. Oops, not to the 10th. All right, to the 11th. All right, so to the 11th divided by 11 plus c. Now let's do another one. So let's look at the next one, see if we can make sense of it. And so we have the integral of 3x squared e to the x cubed dx. And so on this one, all right, what do we want to do? Okay, so again, I want to make a substitution. And the idea is let u be the thing on the inside, or you can think of it, do you see a function in its derivative? Right? If you like the thing on the inside, and you say, okay, well, x cubed's on the inside, then you'd be right. Or you'd say, do I see a function in its derivative? Well, I have 3x squared. Its derivative is 6x. I don't see that anywhere. Or I have x cubed, and its derivative is 3x squared. So that's the one I want to choose. So I have x cubed here, and its derivative, du, is equal to 3x squared. And now I'm going to substitute back in. Right, I'm going to substitute in for x cubed. So here's my x cubed, right? And that's my u. Right, here's my x cubed, and that's equal to u. And then over here, this is my du. Oops, I forgot to write dx over here. Right, make sure you write dx. Right, so this is my du. And so this is equal to the integral of, I have e to the u, and 3x squared dx is just to e to the u. And this, again, it's one of my 4 types. Right? It looks just like this. If I don't have to write an x here, this could be a u. It's the same thing. So the integral of e to the u du is just equal to e to the u plus c. And then I substitute back in here for the u, and so I get e to the x cubed plus c. Let's fix that stupid u. All right, so that's e to the x cubed, there we go, plus c. And that's my answer. Now you can check these, right? Up here I could check this one, take the derivative of 11 would come down, they'd cancel, x squared plus 1 to the 10th, times the derivative of the inside, 2x plus 0, so I get it back. Here, same idea, e to the x cubed, derivative of e to the x cubed is e to the x cubed, times the derivative of the inside, which is 3x squared, and plus 0, so they check out. All right. Let's take a break here, so you can pause the video if you want, and try the group work, and then just do part A, and then when you come back, I'll go over it with you. So take a minute, try to do part A on the group work, and then I'll go through it with you. And I'll tell you the answer here. So on the group work, so you know if you got it right or not. All right, so we have the integral of 3x squared times x cubed minus 7 to the 4th power dx. Right, after you go through this, you should get this to be equal to x cubed minus 7 to the 5th power divided by 5 plus c. Alright, so take a minute and try to do this problem. Alright, so hopefully you tried this, and what you should do is you should make your u substitution. So let's let u equal the thing on the inside, or you say, here's the function, there's its derivative. So u is equal to x cubed minus 7. And in this case, then du is equal to 3x squared dx, right? So take the derivative of this. And then you plug back in. So let's change colors up here. So this is my u. Here's my u right there. And then this piece, this 3x squared dx, okay, that's right here, and that's my du. So I just plug back in, and so this is going to be equal to the integral of u to the 4th. Let's move this up. Alright, so this is going to be equal to the integral of u to the 4th. Alright, and then here, this is my du. Alright, so 3x squared dx is just my du. Now this is just a power of u, which I can integrate. I add 1 to it, so u to the 5th divided by 5. Make sure you say plus c. And then I resubstitute in for the u, so u is x cubed minus 7, so I have x cubed minus 7 right here to the 5th power divided by 5 plus c. Right, and this was part A, right, number 1, part A. Okay, and so the next thing we want to talk about, next example, let's look at these, the next set. They're a little bit different. All right, so on here, what I have for example 2, let's see how they're different. All right, part A, I have the integral of x times x squared minus 1 to the 10th dx. All right, I'm going to use substitution, right, the integration by substitution. All right, so I have to figure out, okay, what am I going to make my u? And I have two choices. I can let it be x or x squared minus 1. If you try to let it be x, you won't get anywhere. And so it's this thing on the inside, right, this x squared minus 1. And so I take the derivative du, and that's equal to 2x times dx. And I go to substitute back in. Right, so here's my u. But I have a problem. Right, here I just have x times dx. And I do not have the 2x dx. But it's really not that big a deal because I can get rid of this 2. I can move it over. How can I move it over? Well, I'm multiplying, so I just divide. So this is du over 2 is equal to x dx. Right, so now, here's my x dx. I can just plug this in, du over 2 for the x dx. So this is equal to, I have u to the 10th, and so x squared minus 1 is my u to the 10th, and x dx is du divided by 2. And then I can do a little bit of algebra here if you like, and just move the 1/2 outside the integral sign. It's probably the easiest way to do it. So that's 1/2 the integral of u to the 10th du, and that's just a power of u, so I add 1 to it, and I divide. So 1/2 u to the 11 over 11 plus c, which is equal to u to the 11th divided by, right, 2 times 11, which is a 22, plus c, right, which is just equal to, plug back in, so I have x squared minus 1 all to the 11th. Okay, that was my u, all divided by 22 plus c. And that's my answer. On the next one, part B, I have the integral of e to the 7x dx. Alright, so now I look at this with fresh eyes, right? I say, okay, it's not one of my 4 types, right? One of my 4 types being a constant, a power, just e to the x, or 1 over x. Right, so there's not much I can do with it as it is now. So what I need to do is I need to make a substitution. So I have to let u equal, and there's only one thing it can be equal to, and that's 7x. So u is 7x, and then du is equal to 7 dx. And so I come back over here, and let's see if I can identify my part. So that's going to be my u. That's easy. And then all I have left over is this dx part, And I don't have dx over here. I have 7 dx, but that's okay because I can move over the 7. I can just divide both sides by 7. And so du over 7 is dx, and I can just plug in here. So this is equal to the integral of e to the u, because that's 7x, and then dx is du over 7. And the easiest way to integrate this is just pull out the 1/7. You divide by 7, it's the same as multiplying by 1/7. The integral of e to the u du, which is equal to integral of e to the u is e to the u, right, of course, times 1/7, so divided by that 1/7 plus c. And then plug back in for u, and so that's e to the 7x, again, u is 7x, divided by 7 plus c. And remember, you can check your answers here. It just becomes a little bit harder because the functions are harder. So like if you want to check your answer, take the derivative of this thing. So derivative of e to 7x divided by 7 is e to the 7x times the derivative of the inside, which is 7, so 7's cancel, plus 0, and you just get e to the 7x back. All right, so let's do the next group work problem. So I'll write it down here, and then you can pause the video and work on it yourself. So part B, on this one, all right, what do we have? Well, we have the integral of e to the 5x dx. All right, so make your substitution, and you should get out for an answer. This should be equal to 1/5 e to the 5x plus c. And once you finish that one, you can continue on and try the next one, part C. All right, so try this one too. So the integral of x divided by x squared minus 1 dx. And for this one, you should get an answer of 1/2 ln absolute value of x squared minus 1 all plus c. So pause the video and try these two, and then come back when you're done. All right, so on part B, you're going to make a u substitution. So you're going to let u equal, and it's just going to be the 5x. That's really your only choice, so 5x. And then du is equal to 5 dx. Right, derivative of x is 1, so you should get the dx back. And so we're going to get this to be equal to, and we can see here's the u, right here. There's my u. But then I just have dx left. And over here I have 5 dx, but that's okay. I can divide both sides by 5, so du divided by 5 is equal to dx. And then I can make my substitution. So this is going to be equal to the integral of e to the u times du over 5. And I can pull out the 1/5. Right, so pull out that 5 in the denominator. So I get 1/5 the integral of e to the u du, which equals 1/5 e to the u, because the integral of e to the u is e to the u, plus c. And I substitute back in, so u is 5x, so I put a 5x where I see a u, and I get my answer. The next one's a little harder. So on this one, I have two choices. I can let u be x, or I can let u be x squared minus 1. If you let u be equal to x, you'll get the same thing back, so it's not going to help you. So I let u be equal to x squared minus 1. And then du is equal to 2x dx. All right, so here's my u, so no problem there. I have my u. But here I have x dx, right? And over here I have 2x dx. And so what I need to do is I need to figure out, how can I turn this into x dx? And it's real simple. I just divide both sides by 2. I get du over 2 equals x dx. So when I come back over here, and before maybe I substitute back in, maybe it'll be easier if I write it like this, as the integral as 1 over x squared minus 1. times x dx. Right? That's the same thing as above, right? Remember, basic algebra and arithmetic. If I have 2/3, that's the same as 1/3 times 2. That's all I'm doing here. I separate the fraction, but it makes it a little bit easier for me to see that here's my u, of course. There's my u. And then this x dx is my what? Well, it's just my x dx right here, my du over 2. So I substitute back in. This is equal to the integral of 1 over u du over 2, because that was x dx. I can pull out the 1/2, so I can write this as 1/2 the integral of 1 over u du. And I can integrate 1 over u. It's one of my 4 types. So this is 1/2 ln of absolute value of u plus c. And now I substitute back in for u, so u is x squared minus 1, so I have 1/2 ln of absolute value of x squared minus 1 plus c. All right, so in the last one we're going to do together, so let's do part D together. So on here, part D, this one, I have the integral of x cubed, and then I have a square root, and 2x to the 4th, and then minus 1, with the dx on the end. And so again, I can make my u. You have 2 choices, really, x cubed or 2x to the 4th minus 1. If you let it be x cubed, the derivative of x cubed is 3x squared. I don't have that anywhere. But if you let it be 2 times x to the 4th minus 1, its derivative is 8x cubed, which is almost x cubed, right? And you can be off by a constant, because we can divide it out. So this one's going to be 2x to the 4th minus 1, and then du is going to equal 8x cubed dx. Right? And I can already see I'm going to have to move over that 8. Right? Du over 8 is equal to x cubed dx, because I do not have an 8 in front of the x cubed. So when I go back to substitute in for 2x to the 4th minus 1, when I come back here, what I see is that this is a u. Great. And then this thing, x cubed dx, right, so here's my u, and that x cubed dx is actually du over 8. So this is equal to the integral of u, and it's square root, so I'll put u to the 1/2, and x cubed dx is du over 8, and that's equal to, you can pull out the 8, so that's 1/8 the integral of u to the 1/2 du. And this is just a power of u, so I add 1 and I divide by it. So this is 1/8 u to the 1/2 plus 1 divided by 1/2 plus 1, right, plus c, which is equal to 1/8 u to the 1/2 plus 1, that's 3/2, right? Half a cup plus 1 cup is 3/2 of a cup, and then divided by 3/2 plus c. And on here, now I'm going to divide by a fraction, so I multiply by the reciprocal, so this is going to be equal to 1/8 times 2/3 u to the 3/2 plus c, and I can simplify this a little bit, right? 2's will cancel here, so if I cancel this with this, I get 4, and so this is going to be 1/12, 4 times 3, u to the 3/2 plus c, and I plug back in for u, so u is 2 times x to the 4th minus 1, so I have 1 over 12, times 2x to the 4th minus 1, all raised to the 3/2, let's raise to the 3/2, plus c. And that's my answer. All right, next time when you come back on Friday, what we'll do is we'll lecture about how we use the fundamental theorem and integration of substitution to do definite integrals. So our goal will be to do something like, how would you integrate something like the integral from 0 to 1 of 2 over 1 plus x dx. All right, so what is this equal to? And so you'll have to use integration by substitution. Right? But you have to actually worry about these limits of integration. They'll actually change when you make a substitution. And that's what we'll do next week. But you know enough to do the homework online. I guess maybe I should write down the homework here. So the homework online, your homework for not tonight is 5.4 integration by substitution, part 1. All right, now let's do well,